For centuries, humanity has looked to the stars, wondering how the universe began. Every new telescope brought us farther into the cosmos than ever before, but nothing prepared scientists for what happened when the James Webb Space Telescope opened its golden mirror. Within months, it began capturing images unlike anything humanity had ever seen. Galaxies that seemed far too old to exist. Massive black holes appearing much earlier than expected. The birth of stars hidden behind thick clouds of cosmic dust. And distant planets whose atmospheres could finally be studied in remarkable detail. Each discovery answered old questions, but created even bigger ones. Some astronomers have even said Webb is forcing us to rethink parts of how galaxies formed after the Big Bang. So, how did one telescope change astronomy? And what has it actually discovered? The James Webb Space Telescope was not built to replace telescopes like Hubble. It was built to go beyond it. While the Hubble Space Telescope observes visible light, Webb is designed to detect infrared light, light that has been stretched across billions of years of cosmic expansion. This matters because the oldest light in the universe is no longer visible to the human eye or standard telescopes. To capture this faint signal, Webb carries a massive 6.5-meter mirror, more than 6 times larger than Hubble's. After launching in December 2021, Webb traveled nearly 1 million miles from Earth to a stable position known as the second Lagrange point, or L2. There, it is shielded by a tennis court-sized sunshield, allowing it to operate at temperatures colder than -370 degrees Fahrenheit. In this frozen darkness, Webb can detect the faintest heat signatures from the earliest parts of the universe. Scientists expected it to reveal the first galaxies, but what they found went far beyond expectations. Looking into space is also looking into the past. Light does not travel instantly. The sunlight reaching Earth is already about 8 minutes old. Light from nearby stars can take years to arrive. And the most distant galaxies observed by Webb emitted their light over 13 billion years ago. When Webb released its first deep-field image, a tiny patch of sky transformed into something extraordinary. Thousands of galaxies appeared in what once looked like empty space. Some of them existed just a few 100 million years after the Big Bang. For the first time, humanity was seeing the early universe in incredible detail. Then came one of Webb's biggest surprises. Scientists expected early galaxies to be small, dim, and slowly forming. Instead, Webb found galaxies that were bright, massive, and already highly developed far earlier than predicted. This does not break physics, but it suggests that galaxy formation may have happened faster than previously believed. In other words, the universe may have evolved more rapidly in its early stages than our models suggested. This is how science advances, not by proving everything wrong, but by refining what we thought we knew. Another major discovery came from something even more extreme. Webb detected signs of supermassive black holes existing very early in cosmic history. These black holes were already millions or even billions of times the mass of our Sun. The question is how they grew so large, so quickly. Did they form from unusually massive seeds? Or is there a growth process we have not yet discovered? Scientists are still working on these questions, and Webb is providing the data needed to explore them. One of Webb's greatest strengths is its ability to see through dense clouds of dust. Where visible light is blocked, infrared light passes through. This allows Webb to reveal regions of space that were previously hidden. One of the most famous examples is the pillars of creation inside the Eagle Nebula, where new stars are forming deep within thick gas clouds. Instead of darkness, Webb reveals glowing stars, swirling dust, and planetary systems beginning to form. It is like switching from a blurry image to ultra-high-definition vision of the universe. But Webb is not only looking backward in time, it is also studying planets beyond our solar system. When a distant planet passes in front of its star, a small portion of starlight passes through its atmosphere. Webb analyzes that light to determine what the atmosphere is made of. Using this method, scientists have detected water vapor, carbon dioxide, methane, and sulfur dioxide in distant exoplanet atmospheres. These findings do not confirm life, but they show that Webb can identify the chemical building blocks that may support it. This brings us to one of the biggest questions in science. Are we alone in the universe? So far, we do not know. But Webb is giving us the tools to find out. To understand Webb's impact fully, it helps to compare it to earlier telescopes like the Hubble Space Telescope. Hubble changed our understanding of the universe by giving us deep images of distant space. But Webb takes that further by observing in infrared light, revealing objects Hubble could never see. Where Hubble saw faint smudges of distant galaxies, Webb sees structured systems. Where Hubble reached the edge of early observation, Webb is pushing closer to the beginning of time itself. The difference is not just improvement, it is transformation. One of the most surprising findings from Webb came from the early universe itself. Scientists expected small, slow-forming galaxies. Instead, they found large, bright galaxies already forming just a few 100 million years after the Big Bang. This suggests the early universe may have evolved faster than expected. It also suggests that some parts of galaxy formation may need refinement, and that means the story of the universe is still being rewritten. Even now, the James Webb Space Telescope continues its mission. It is searching for the very first stars ever formed. It is studying how galaxies evolved over billions of years. It is analyzing distant planets for signs of chemical activity. And it is continuing to uncover surprises that scientists did not anticipate. Each new observation adds another piece to a puzzle that is still incomplete. And perhaps the most important discovery of all is this: we still have so much left to learn. The James Webb Space Telescope has not finished its mission. It has only just begun. And if history has taught us anything, it is that every time humanity builds a better window into the universe shows us something we never expected to see. And Webb has opened the clearest window we have ever had.